Hey everybody, it's Dr. Jensen with CCJ 3701, Research Methods in Criminology. I thought I'd do a quick video just to make this table a little less intimidating to build. So again, this table has to do with linear regression. So you can kind of use it as a template. I have lots of little templates for you guys to drop your numbers into. But the way this table is organized is we call this nested modeling. So remember, every regression you run is SPSS or statistics trying to graph or create a hypothetical line that illustrates a relationship between two variables. Does knowing this about you let me predict that about you? That's it. Okay? And that line that's going to help us know how it works is going to have a slope, it's going to have a y-intercept or a constant, and it's going to have as a level of significance and so forth. And so those pieces are what is going to go into this table. So let's walk through it very quickly. Let's say I'm in SPSS and I'm going to run this linear regression. Okay, so again, it's analyze, regression, and then linear. Just to show that to you for a moment. Analyze, regression, linear. I go grab my variables. Okay, so I'm going to actually do family income as my dependent, and I'll grab a variable up here. And again, these would be maybe recoded variables that you've already worked with and so forth. I will grab this variable here for an independent. Okay. Again, ask for statistics and descriptives so you can get those cases and that N. And click continue and click OK. So this would be the regression of your first model. Okay. So in your output, you have this new little box you haven't really seen. See this N? This shows you how many cases you're actually analyzing. So remember, we have two variables in this regression equation for this hypothetical line we're trying to make. And the two variables are family income and how often they attend religious services. So the family income is the interval dependent variable, and the how often you attend religious services would be the ordinal independent variable. So as far as how many people answered both of those questions so that we could regress them against each other, it was 1,771. Okay? So that's what's going to go in your table right here for N. So on model 1, we would put 771 there. Okay? So that's the first thing you do. Secondly, you scroll down here. You always get this thing that says correlation matrix. Okay? So you get that, but that doesn't go in our table. Okay, we're going to scroll down a little bit more until we get to model summary. Model summary, this is where our R-squared value is. It's almost, well, it's definitely 0. So if you ever get triple zeros like this, that's okay, just report it anyway. So in your linear regression, you would put R-squared is 0 or whatever the value is there. Okay? So that's where that goes. Now, scroll down a little further, we get our famous ANOVA right in here. And again, these correlations and ANOVAs are really just a part of the analyses that eventually create your regression coefficients. So you can kind of ignore those for now. But if we go down here to coefficients, this is the box where the rest of our table comes from. So here we have dependent variable is family income in dollars, and then our independent variable is the religious services and whatever it was named when you coded it or where you pulled it out of the data set. So here we get the B coefficient, 128.56, okay? You get a standard error, a beta, and T and significance level. Okay, so let's talk about what goes in your table. The B coefficient, this 128.56, that goes right here. So we would have a variable that was called how often you go to religious services. And then the B coefficient would go right next to it underneath model 1. Okay, and then it would get stars depending on whether or not it was significant. We'll talk about that in a moment. Okay. Now down here, you also see constant, 50,252.658. That constant, remember, is the y-intercept, or where, where we cross the y-axis when x is 0. So x is our independent variable, y is our dependent, meaning if we know nothing about you, what would your family income be in dollars? Well, it would be about $50,252. That would be our constant. That also goes in your table. So for constant, you actually put that $50,000 mark right there. Okay? So these are all the little pieces go. Now the stars. Let's talk about this. Remember, this is our key to what the stars actually mean, things significant at various levels, and that p-value kind of stands for probability value that that is actually true and that those things are related in that way beyond just chance. Going back to SPSS, if we look, it's very easy to get mixed up and have our eyes jump to this top line that says constant. All we really use for this top line for constant is this value here. And it kind of bugs me how SPSS puts the constant right underneath this B column because it's kind of confusing. Okay, but the constant's always the first row in the linear regression, and then all your variables are underneath the constant that shows you those little B coefficients. Those are the slopes of the line. Okay, but again, the significance level, make sure you're on the right row for the religious services variable is 0.736. Okay, is that a significant value? No. Again, we want tiny little values like this. Okay, that's way too big. That means I only have a 0.73 chance or a 73% chance of it not being true. That's pretty bad. That means I only have like a 27% chance of it being true, which is terrible. That we have much higher standards for social science. So we take that little significance value. In this case, it's too big. It's not significant. So in this case, we would just take off the stars, okay? And it would just be a coefficient by itself, okay? So if it was significant, then depending on at what level it was significant, we would give it either 1, 2, or 3 stars. Now remember, when you read these little values, this was super confusing to me when I first started statistics. I never really knew how many stars to give it or how this actually worked. So let's go back to those little stars. Remember, if your significance level is less than 0.05 or 5/100ths, then you can give it 1 star. If it's even smaller and it's less than 1/100th, because 1/100th is less than 5/100ths, then you can give it 2 stars. If it's even smaller than that, it's triple zeros or it's 001, it's 1/1000th or smaller, you can give it 3 stars, meaning we have a very, very tiny chance of our result being false or wrong, and a very, very large chance, over 95 or 99% chance, of it being true or correct. Okay? So people are like, well, what if I get like a 0.02? Do I give it 1 star or 2 stars? Okay? If it's 0.02, you give it 1 star. Okay? It's within the 0.05 level, but it's a little too large to give it the 0.01 level, because 0.02 is larger than 0.01. So we actually just keep it with 1 star at the 0.05 level. So it has to be at that level or tinier until you get to the next level. So what if you got a 0.003? Where would that one go? Well, 0.003 would get 2 stars. Okay? It's 0.003 is a little too large. 3/1000ths are bigger than 1/1000th. So you can't give it 3 stars, but you could give it 2 stars because it is certainly smaller than 0.01, so you give it 2 stars. Okay? So always find out what number it fits within or between to determine how many stars it gets, and then you just put those stars in the table next to the coefficient of the variable you're talking about. Okay? So that's how you do one model. Let's show you a second model. Okay? So you're going to now work on model 2. Models 2, 3, 4, etc. are when you add another variable. So if we go to regression, linear, it's going to save the stuff you just did. Let's add another model, okay? Or I'm just going to choose kind of a random variable. Again, you would choose the variables that you've worked on, okay? Let's try this one, okay? And so you actually just stack them in here, right, in this block box, okay, when you add a second variable. Again, you've already asked for those descriptive statistics, so you can click continue from that option box and then click OK. So now we have a new regression right underneath our last one we did, and it has new output. Okay, so here's the regression. Okay, here's those descriptive statistics. Look, our sample size really shrunk. Now we only have 121 people. Okay, this is a variable that talks about how many people you employ, so not everybody's a supervisor or a business owner, so it's not going to apply to a lot of people. We only have 121. So you would put that new n in your table. So now I have a new n for model 2, in this column right here. So I'm done with the first column. Now I'm working on the second. And then I scroll down. Here's the correlations, the variables. Okay. Here's the model summary. That's my new R² value. It actually increased a little bit, getting a little more explanatory power. So I'd update that right here in the R² value for model 2. And then here's my famous box of coefficients. Now you see I have my first coefficient. Okay, it looks like I got a negative coefficient now. And then I have a second variable with its own coefficient. Remember, every time you add a variable to the equation of a hypothetical line, each of them have their own little tug or pull on that line. They each contribute something to that line and making that line better and better in trying to explain this hypothetical relationship. So they each get their own slope. So here's the slope for this variable, here's the slope for this variable, and each of them also have a significance level. Okay, so this is where you would record each of those coefficients. Okay, so in model 2 we would update the coefficient for the first variable, and then we would also put the coefficient for the second variable. This is also where we would put in the new constant as well as the R². Okay, and you'd want to put your stars on the variables that matter. Okay, now again down here we have a variable that's not significant, that religious services one. It still isn't significant, so it still doesn't get any stars. Here, the employment variable actually is significant. It's kind of a weird one to interpret. But look, it's 0.014. Aha, that's a nice small number. We like that. High probability that it's actually true. So if it's 0.014, what p-value is it? Take a second to decide. This one's a little tricky. You could kind of argue that if you just went to 2 decimal places, it really is a 0.01, so you could just give it 2 stars. But some people say, well, technically 0.014 is a tiny bit larger than 0.01, so probably the safest bet is to put it at the 0.05 level. Okay, and some people are really conservative that way and they do that. Other people say, well, I don't want to use 3 decimal places, I just want to use 2, so therefore it fits at the 0.01. You could kind of argue either way, and I've seen lots of good journal fights where people do that, but in either case you could, to be super safe about it, you could just put 0.05, but it wouldn't be problematic to put 0.01 either because it is so darn close and a lot of people just round it off. Okay, so that's acceptable too. Okay, so you could kind of go either way depending on how you want to argue about it. But again, you would update those pieces of information in here, and you can see each variable that I'm going to test is listed one right after the other, and then each model introduces another variable one at a time. Okay, so this person actually had lots of variables they wanted to test, so they started introducing multiple variables into new equations, and you can do that too if you have more than 3 variables you want to add into your test. You don't have to. I only require 3. Some people want to do 6 or 10, and that's up to you. You just have more to analyze and more to do. So depending on your time and your interest, I'll leave that decision up to you. Okay, but again, you just go ahead and in your column populate it accordingly as you keep running each model. So going back here, now we would go back in SPSS, and again, you can use those menus from your output view if you want to. Linear, add in your next variable, click OK, and then you'll start to see how those regressions change as you add more and more to the equation. Generally speaking, the more variables you add to the equation, the smaller your sample size tends to get, but usually the larger your R² gets, because the more you know about somebody, the better you get at predicting things about them. So you'll generally see that value grow, and you can kind of talk about that when you write up results. The constant will change slightly. It usually doesn't change drastically. But sometimes, you know, a variable by itself isn't significant, but suddenly you put it with something else and it is. We call that an interaction. Sometimes variables have little effects on each other and they can amplify their power. So you'll see some very interesting little things that come up that's really fun to talk about. Okay? But essentially that's a table. That's how you populate a table, and that's why I recommend people going ahead and running all their results, getting their analyses put together, taking all the relevant pieces out of the SPSS output, popping it in the table, and then just taking the table and writing a paragraph about this, a paragraph about this, paragraph about this, and then one about this. It's a really pretty straightforward way to do it. And again, if a variable isn't significant, not much you can really say about it. All you can say is, you know what, income and age wasn't really significant. Moving on, okay? But this is where you start writing all these little sentences about the pieces and what they mean. Thanks.